Chemical reactions and equations. Writing a chemical equation. So we are going to learn about this topic. Chemical reactions happen all around us in our day-to-day life. A chemical equation is a symbolic representation or shorthand that is used to describe a chemical reaction. We have already learnt about reactants and products in previous module. Going further, let's understand types to represent any chemical equation. So, chemical equations can be written in two forms, namely word equations and symbol equations. As we have earlier discussed, in a word equation, the names of the reactants are linked together with those of products. But in a symbol equation, these are described using symbols and formulae of reactants and products. So, let us see the example. This is how we write methane plus oxygen forming carbon dioxide plus water, right, in the word equation form. However, in symbol equation, it is described like this. CH4 plus O2 forming CO2 plus H2O. Here, CH4 is the symbolic form of methane. Similarly, O2 is the symbolic form of oxygen. Let us consider our previous example. So here, magnesium plus oxygen giving magnesium oxide is how we write in word equation. However, in symbol equation, we write the same equation as Mg plus O2 forming MgO. So you can clearly see the difference between the word equation and symbol equation. It is quite convenient to write the equation in its symbolic form. Can you see this picture with some symbols written on it in white? It's not really any weird stuff or something, but it is a symbolic representation of many long reactions which we have to use in our higher classes. You will actually be used for symbolic representation only because writing a word equation every time is very much time consuming, especially in longer equations. Now, count and compare the number of atoms of each element on left hand side and right hand side of the arrow. Is the number of atoms of each element the same on both the sides? Just consider this example, Mg plus O2 forming MgO. See, magnesium is 1 on each side, right, which is Mg. But oxygen is 2 on the left hand side and 1 on the right hand side. Why is it so? And is it correct? Let us understand this further. Chemical equations are classified as balanced and unbalanced equations based on whether they have equal number of atoms on both the sides of equation or not. You are confused? Don't worry, I am here to explain you. So basically, in a balanced equation, number of each atom will be same on both the sides of the equation, while in an unbalanced equation, either of the side will have more atoms of the same type than another. You will get an idea about this when we work on an example. But before going further, let's understand why this balancing is that important. Why do these number of atoms of every element have to be same on both the sides? What if they aren't same? This is explained better by law of conservation of matter, which states that matter is neither created nor destroyed. The amount and type of chemical elements remain the same before and after the chemical reaction. They are simply rearranged into different chemical compounds. Okay, so this is a law of conservation of matter, and we actually balance equation. Like these unbalanced equations are meant to be balanced for following this law, okay, law of conservation of matter. Now let's dive deeper into this with a displayed example. Here we can see these two symbolic equations, CH4 plus O2 forming CO2 plus H2O and Mg plus O2 forming MgO. Let us consider the first equation. How many carbon atoms whose symbol is capital C do you see on the left and right hand side of the first equation? We have 1 on each side, right? 1 on the left hand side is in CH4 and the 1 on the right hand side is in CO2. Now let's count the hydrogen atoms which are represented as capital H. Yes, there are 4 on the left hand side in CH4. However, there are only 2 on the right hand side in H2O. This clearly disobeys the law of conservation of matter. And so, in order to follow this law, it is quite important to balance any equation. If you see the second example, there are two oxygen atoms on the left hand side but only one on the right hand side. So from this, what do we conclude? Quite logical. Both of these equations are example of unbalanced equation. We will now learn how to balance these chemical equations in upcoming modules. Thank you.